Determinants. So determinant is the function that associates a number with any square matrix. We denote the determinant by a matrix of a matrix A by writing det A or A in the straight line. This does not mean that this is absolute value. That's a notation for determinant. Okay, so we either denote that the det of A or straight line of A. And now for a 2 by 2 matrix, the determinant of a matrix A that has A, B, C, D terms is nothing else, determinant in straight line, and then we cross multiply A times D minus C times B. That only works for 2 by 2 matrices. So once you have 2 by 2 matrix, to find determinant is straightforward. Cross multiply A times D and subtract whatever is multiplication on the other diagonal. What's important is that notation. A matrix is denoted in square brackets, determinant in straight lines. So if you have straight lines, that means you need to find determinant. If you have square brackets, that means it's a matrix. So we have simple example how to apply this formula for 2 by 2 matrices. So we have find the determinant of a matrix A that is equal to 1, minus 1, 2, and minus 3. Okay, so determinant of A, I can write that in straight line 1, minus 1, 2, and minus 3. And now as the formula goes, cross multiply 1 times minus 3, 1 times minus 3, and then we have minus 2 times minus 1. So now perform those operations. Now perform those two operations. So we have 1 times minus 3 is minus 3, minus 2 and minus 1 is plus 2. So minus 3 plus 2 is minus 1. So determinant of A is just 1. If we would like to find a determinant of a matrix of higher order, that means the matrix not only 2 by 2, but 3 by 3, 4 by 4, and so on. We can only talk about determinant for a square matrix, 2 by 2, 3 by 3, 4 by 4. If number of rows is not equal number of columns, we cannot talk about determinant. Okay? So if we would like to find the determinant of the higher order matrix, we need to first define a couple things. So I have definition. Let A is equal to Aij. So let me first explain what is Aij. Any matrix, a matrix A that has number 1, 2, 3, 4, we can keep writing that this number is the position first row, first column. So we say that this is position 1, 1. Or we can say that the first term is denoted as A1, 1. Or in general, I can write that the matrix is A, first term is 1, 1. This term is first row and second column. So I will denote 1, 2. Then we have second row, first column, and then we have second row, second column. Okay, so this is A1, 1, A1, 2, A2, 1, A2, 2. Or you can use any letters, B, C, or whatever. Those positions just tell you what position of the number it is. So the first number is always row, and the second number is column. So for example, this is second row, and first column. Okay, so the corresponding term to the second row, first column, is 3 for this matrix. Okay, so now we have definition. Now we have definition that let A is the matrix of Aij. So in general, I'm writing Aij. I'm writing that this is Aij, Aij 1, 1, 1, 2, 2, 1, 2, 2, and so on. It can be more. Be a square matrix of size greater than 2. Then we have definition. The minor of Aij, denoted by Mij, is the determinant of the n minus 1 by n minus 1 matrix formed by deleting the ith row and the jth column. Please stay with me. I will show an example. It's very simple and straightforward. What is the minor? Okay, that's just definition. In 1 second, we will have examples. And then cofactor of Aij is nothing else. Cofactor will denote by Cij is minus 1 to the power I plus j times the minor ij. Now it's confusing, but please stay with me. Okay, so for the given matrix, let's say that we have here example. For the given matrix, this matrix, find the minors and cofactors. M21, M31, those are minors, and then we have cofactors. So first we would like to find minors. First we have minor 2, 1. Okay, so that minor 2, 1. So for this matrix, I will rewrite my matrix 2, minus 3, 5, minus 2, 1, 3, 1, 3, and minus 2. So minor 2, 1. That means find the term corresponding to 2, 1. So means second row, first column. Second row, first column is this number. Okay? So minor of 2, 1 is nothing else. You delete second row and the first column. If we delete and then find the determinant. So if we delete second row and first column, what are we getting? 2, 1, delete second row and the first column, and find the determinant of what's left. So what is equal to the determinant of minus 3 and 5, and then 3 and minus 2. Okay, this says 2, 1, second row, first column, delete, and then find the minor. That's the definition of the minor. Is the matrix obtaining by deleting the I and jth row and column. Okay, so now determinant of 2 by 2 matrix, we should know that we cross multiply minus 3 times minus 2 plus, minus, by definition goes minus, subtract on the other diagonal is 3 times 5. So minus 3 times minus 2 is 6 minus 15. So 6 minus 15 is nothing else but minus 9. So the minor 2, 1 of this given matrix is minus 9. Okay, if we had question, there is no question like this, but if we had question, find cofactor 2, 1, so cofactor is nothing else but minus 1 to the power of those what you deleted, second row and first column, so it would be 2 plus 1 times the minor of 2, 1. Okay, so cofactor is nothing else. minus 1 to the power 3 is minus, and then the minor is minus 9, so the cofactor would be 9. Okay, let's find the other ones. We have minor 3, 2, so we need to delete third row, second column. So we can rewrite the matrix, so this would be B. Rewrite the matrix, 2, minus 3, 5, minus 2, 1, and 3, 1, 3, and minus 2. So now to find the minus 3, 2, delete third row, second column. Third row, second column is deleted. So what's left? We put straight lines for determinant. So what we have, 2 minus 2, and then 5 and 3. And now find this determinant. So we just go straight forward, cross multiply. 2 times 3 minus, on the opposite side, minus 2 times 5. So this is equal to 2 times 3 is 6, and minus 10 plus 10, so the minor is 16. So M32 is 16. Okay, see, we need to find cofactor. So cofactor, you just only add this minus 1 to the exponent, that's by definition. See, we need to find cofactor 2 by 2. So let's copy by definition, this would be minus 1 to the power 2 plus 2 times the minor of 2 by 2. Okay, so those 2 and 2 we are getting from IJ right here. So let me copy the matrix, 2, minus 3 and 5, minus 2, 1 and 3, and 1, 3, and minus 2. So we need to find the minor 2, 2. That means second row and second column, delete second row, second column. Second row, second column are deleted. So what's left? So let's write that cofactor 2 by 2 is equal to minus 1, 2 plus 2, times this minor we are writing that if we delete second row, second column, we have left 2, 5, 1, and minus 2. So this is equal to minus 1 to the power 4 times cross multiply 2 times minus 2 minus cross multiply 1 times 5. Put in the bracket because we need to work this out. So minus 1 to the power 4 is 1. 2 times minus 2 is minus 4. And minus 5. So this is minus 9. So cofactor of 2, 2 is nothing else but minus 9. Go ahead and try to find cofactor of 1, 3 in similar ways. In similar way. So D, that cofactor C1, 2, copy the matrix, 2, minus 3, 5, minus 2, 1, 3, 1, 3, and minus 2. And the cofactor by definition is nothing else but minus 1 to the power 1 plus 2 times minor 1, 2. Minor 1, 2 means first row, second column. Delete first row, second column. And whatever is left is your minor. So the cofactor 1, 2 is nothing else. Minus 1 to the power 1, 2 times minor is the determinant what's left. So it's minus 2, 3, 1, and minus 2. So this is equal to minus 1 to the power 3 times cross multiply minus 2 times minus 2 is 4 minus cross multiply 3. So minus 1 to the power 3 is minus 1 times 4 minus 3 is 1 So this is equal to minus 1. So cofactor 1, 2 is nothing else but minus 1. So now we are using the cofactors, the minors, to find the determinant. To find the determinant of a matrix of order higher than 2, we use cofactor expansion along any row or any column. I will show you what does that cofactor expansion means. So we have example, find the determinants, and we have A. We have determinant of 2 minus 3, 5, minus 2, 1, 3, and then we have 1, 3, and minus 2. I would like to expand by the first column, let's say. Doesn't matter. First column, first row, second by any column or any row. So, to expand by the first column, this would be equal to expand by first column. So the determinant is equal to first the number, what is the first column is number 2, times the cofactor of the position of that number. Number 2 is in the position 1, 1. Then we have plus second number from this. You need to write all the numbers from the first column. So now we have minus 2 times the cofactor of the position. This one is second row and first column. Plus number, write the number and the cofactor of that position, third row, first column. Okay? Then we need to work this out. But that's basically how it works. Every number from this column, you need to write it down. Number 2, minus 2, and 1. So it's number 2 times the cofactor of the position. What is that number? This number is in position 1, 1. First row, first column. Now the second number is minus 2 times the position. What is that number? Is second row, first column. And then we have number 1 and it's third row, first column. Okay? Now be careful. Now we need to work this out. So what we have? Number 2 times cofactor was minus 1 to the power 1 plus 1 times the minor. Minor of 1, 1. So delete the first row and first column. And what is left is your minor. So your minor is 1, 3, 3 minus 2. Then we have plus minus 2 times cofactor was always minus 1 to the power of 2 plus 1 times delete second row and first column. So delete second row and first column, and what is left is minus 3, 5, and 3 minus 2. Plus we have 1 times minus 1 to the power 3 plus 1, and delete third row, first column. So what is left? We have minus 3 and 5, and then we have 1 and 3. First row, third column. For this one we delete first, second, and that's it. And now we need to solve it. That's the determinant. Okay? Now we need to solve it. So minus 1 to the power 2 is just 1, is just positive 1. So we have just 2. I will maybe use new paper. Okay. From this one we have minus 1 square is just positive 1 times 2 is just 2. And cross multiply those two. So we have minus 2 minus 9. Put in the bracket because we need to subtract them. Now from this one, minus 1 to the power 3 is minus 1 times 2. Minus 2 is positive 2. Cross multiply. Minus 3 minus 2 is positive 6. Subtract what's on the other one is 15. And then we have minus 1 to the power 4 is positive 1, so we have plus 1. Cross multiply is minus 9 minus 5. And work this out. So this is equal to 2 times minus 11 plus 2 times 6 minus 15 is negative 9. And then we have plus 1 times whatever is minus 14. So we have minus 22, minus 18, and minus 14. So we have 22 and 18 and 14. So the determinant is equal to, this is equal to minus 54. Okay, so that's my determinant. Very beneficial would, please note that very beneficial would be if we expand, if we had some zeros. If you have somewhere 0 on the way, then expand by the zeros, by the row that contains the most zeros, because then you have the least calculations. Then instead of those, if you have 0 here, 0 here, then here would be 0, so you don't need to calculate anything, any cofactor, because 0 times anything is always 0. And here would be 0 as well, and so on. Example 2. So we have B. Okay, we need to find determinant like this: 0, 1, 0, 0, minus 1, 0, 0. Oh, sorry, minus 2 here. Minus 2, 1, 3, 0, 0, 0, 1, 0, minus 1, 1. So expand by something that has the most zeros. We can expand by the first row or by the second column. Choose any one you like. I will go by the first row. Expand by first row. So, write down the number 1 times the cofactor of the position. What is the position of this one? First row, second column, 1, 2. And then it would be plus. Oh, I'm going by first row, sorry. So it should be 0 plus this one plus 0 plus 0. I will write this nicely. I'm sorry. So we have 0 times 1 in the position 1, 1 plus 1 times position of this one cofactor is first row, second column plus 0 times cofactor first row, third column plus 0 times cofactor fourth row. You don't need to write down everything like this. You don't need to even bother about those ones, because this is a 0, this is 0, this is 0. So everything we have left is 1 and that cofactor. So 1 times, let's work out this cofactor, is minus 1 to the power 1 plus 1 times 1 plus 2. Times delete the first row and second column. And so what's left is minus 1, 3, 1, minus 2, 0, minus 1, 1, 0, and 1. And now we need to solve this determinant. So this determinant expand by this row, second row, because it's only one number and the rest is 0. So expand by the second row. We can work this out, by the way. So this one is minus 1 to the power 3 is minus 1 times. Then we have 3 times cofactor of the position is second row, first column. And then it would be plus 0, plus 0. So we don't bother with the rest. So what it is? We have minus 1 times 3 times cofactor always go minus 1 to the power 2 plus 1 times delete the second row, first column, so what's left? Minus 2, 1, minus 1, 1. Okay, so what we have? We have, this would be to the power minus 1, so I have minus 1 times 3 times minus 1 times, multiply this one, minus 2 minus minus 1. Be careful about those. Minus is from the formula, and then when you cross multiply those two. So this is equal to, this is positive 3 times 2 plus minus minus 1 minus 2 plus 1. So this one is minus 2 plus 1. So this is minus 1. So the determinant is minus 3. Example 3c. Okay, we have 0, 1, minus 3, minus 3, 5, 2, 2, minus 5, 3. Find this determinant. So to find this determinant, expand by any row or any column. For this question, it is beneficial to expand either by the first row or by the first column or by the first row. So let's choose first row. So this is equal to, is 0 times the cofactor of 1, 1 plus 1 times the cofactor of 1, 2 plus minus 3 times the cofactor of position first 1, 3. So the first term is 0 and the second one is 1 times minus 1 to the power 1 plus 1. Delete first row, second column, first row, second column. So we have minus 3, 2, 2 and 3. And then we have plus minus 1, minus 3 times, from cofactor formula we have minus 1 to the power 1 plus 3. Delete the first row, third column, so it's minus 3, 5, 2 and minus 5. So minus 1 to the power 2 is 1, so this is basically 1. Cross multiply is minus 9, minus 4. Here is minus 1 to the power 4. 1, 2, here we have mistake, 1 and 2, here should be 2, so here we should have minus 1. Okay, this one is 4, it's plus, so we have minus 3 times cross multiply, minus 3 and minus 5 is positive 15, minus 10. So this is equal to minus 1 times minus 13, and then we have minus 3 times 5. So this is 13 minus 15, so this is minus 2. The determinant is minus 2.